Hey guys, I'm gonna do a video on a good amplifier versus a bad amplifier and sort of the differences between them and why it matters. So if you're getting into professional audio, you definitely want to stay away from something like this. Now this is an amplifier I bought long ago. I mean long ago. When I was lower budget, didn't even know what the hell I was doing. Just getting into audio. I mean this is when I was like, God, I don't know, 10 years old or something like that. I don't even know. Long time ago. So it's just, one of those off-brand knockoff Japanese amplifiers. Let me go ahead and show the front of it to you. It's under the name Glide Pro, and they claim, what's funny is here, so if you look at it, they claim it a 10,000 watt amplifier, and this is anything but a 10,000 watt amplifier. And yeah, I have the sub sticker on there. This is way back. I would never run my sub with this today. The damping factor on it is incredibly horrible. I mean, this is a really good teaching tool to show the difference between a good and a bad damping factor, because this thing has a damping factor of like 100 at most, probably. So, I'm going to show you guys the differences between them, sort of the technologies. This is my QSC PLX3602. This is how a lot of amplifiers, professional amplifiers, are built today, off of the switching technology and a lot more efficient. I'm just going to explain the basics. I'm not going to go into all the... I have a teardown video of this, and I explain everything in detail from, how the power rails work in here, because it's got dual voltage power rails, and it's got a switching power supply, and I explain all the IGBTs, the diodes, and how all these capacitors work and what they're doing, and the filtering and the output circuitry on here. I explain all that. I'm not going to really do much on here on that because there's not much to explain. It's nothing great, grand, or amazing, but I'll just go into explaining it. So this is a poorly built amplifier. You want to stay away from these. You're probably going to want to get a brand name amplifier if you're getting into professional audio. But I would definitely stick away from these here for several reasons, and I'll explain that. So this is a transformer here. So what it does is you have to have a center tap transformer to make audio work. I'm not gonna really explain that right now because that's kind of off topic here. But basically what you have to have is you have to have a line that has 0. Then you have to have 2 other lines in the middle so that you can have a positive or a negative, because they have to be relative to the 0 line to make the speaker move in and out. So you always have to have some type of a transformer and an amplifier. Now how you do that is very important. This is a cheap way of doing it. This is just a big, huge toroidal transformer. This is probably 800 watt or 800 volt amp transformer. There's a difference. See the power factor correction video, and I explain the difference in watts and volt amps. But it's an 800 volt amp transformer, I'd say about. Let me see if there's a rating on it. No, just a bunch of voltage ratings. So it's just got taps coming out of it. 15 volt, 25 volt. What else is there? I know there's, on the output, there's got to be, it's a 52 volt. There's a 25 and a 52, so it's got 52 volt rails, negative and positive. So that's what's actually running the amplifier. I don't know why they would come up with such a weird number like 52, but that's what they came up with. So, then you have this here. Now this transformer here is probably capable of, God, I don't know, these are kind of hard to tell, switch mode. It really depends on what frequency they're running at. I think this is running at, I forget if it's like 100 or 200,000 hertz, but this is probably capable of peaks, maybe 2,000 watts, probably capable of, 1,500 or so continuous, no problem, maybe a little bit more than that. But you got to understand the difference here. This is a huge piece of iron with wire wrapped around it, copper wire. This is a tiny little piece of a ferrite core material with a tiny bit of copper wound around it. Probably weighs, I don't know. I don't know how much it weighs. Maybe a few ounces, half a pound or so at most. So it's very, very light versus this, which probably weighs upwards of maybe 15, 18 pounds thereabout. Maybe 20 pounds for just this single transformer, which is massive. And this thing can't even put out nearly as much power as this. This amplifier truly probably puts out maybe 1,000 watts at most, and it sounds like crap when it does put out that much. But I'm going to explain the difference between this type of a power supply and an amplifier and this type. So I'm mainly going to explain the power supplies. I mean, I can get into a bunch of other stuff like how this has dual voltage rails, better output transistors, and how all that works, but that varies from amplifier to amplifier. This just has, you know, just your standard AB push-pull type of configuration. It's not class H or anything, nothing fancy here, just you have a negative rail on one side, a positive on the other side, and then you just have BJT transistors running. It uses the, see if I can get it in there, 2SC5200s, and I think it's 2SA1943s on the other side, the complementaries, or they might be over here. Let's see if these are them. Can barely see them. I can see that they are 2SA1943, so yeah, they are 43s. You're going to have to take my word on that. So those are the complementary pairs for those transistors, but there's a big difference in these types of power supplies. Let's start off here. This is incredibly inadequate capacitors for an amplifier this size. This is 100% underrated. You can see here there's just two, what do we have, 10,000 microfarad 80 volt capacitors, and then here there are there's six. These are 200 volt capacitors, and then these are a bunch of 90 volt capacitors for the lower voltage rails. So there's two voltage rails here. So I'm going to get into explaining the technical differences between the two and why this is 100% better than this, and how it can really make a difference in your amplifiers, not only in weight and efficiency, but really how it makes the amplifier run. I'm going to draw it out here, so we'll go on to that right now. Alright, so now before I start, I shouldn't always say that these amplifiers are always bad, because QSC makes a RMX series that uses this type of technology. They have a 5,000 watt amplifier, and in comparison, you know, that's going to be an 80-pound. It's an 80-pound amplifier. They have two of these transformers running together, and I mean, it's not the best amplifier. That's one of their lower series. But these amplifiers aren't always bad, but there's a big drawback on the power supplies. So I'm going to explain that here. If we take a look at it, now this makes a big difference when you're driving subs particularly, because your subs are going to pull a lot of power, and sometimes they can have high transient peaks. Let's say it's running a kick drum or whatever. You may have to push that sub at peaking, you know, 2, 3, 4,000 watts, which is a lot of power, versus high frequencies, which usually don't pull that much power, and they don't have that high of transient peaks. So let me draw this out. In an amplifier like this, I explain, I have so many videos on this, it's not even funny. On switching versus linear, I explain how the switching power supplies work and how a normal power supply works. But this is a normal, and this is a switching power supply. So a normal has a sine wave coming into it at 60 hertz, and this is coming 60 times a second. So it's cycling back and forth 60 times a second, and it's pulsing at, it's peaking at 170 volts, 170, and draw your 0, and then this is peaking at 100 or about 200 volts, thereabout, and 0 volts, and this is happening anywhere from 100 to 200,000 times. Let's just say 200,000 times a second, 200 hertz, 200 kilohertz. There you go. That's more like it. So basically, this power supply here is refreshing and charging these capacitors 60 times a second. So this is going to be rectified, and it's going to be, so it goes, what happens is this transformer puts it through the rectifier. There's a bridge rectifier under here, and it goes and charges these capacitors 60 times a second. So it's charging your rails at 60 times a second. Now, this one is charging the rails at 200,000 times a second. There's quite a difference there. So these capacitors here are being recharged and maxed out, topped out, filled up 200,000 times a second. Now it's also worth mentioning that this is a pulse width modulated wave, which means when the amplifier is not pulling that much power, it can run a wave something like this because it is limited by electronics. So it's just running tiny little pulses when it needs to. Versus when it's pulling a lot of power, it can crank the wave up very high duty cycles like this, and it pushes out a lot more power when it needs it. This is just power coming from your wall. This is never ever going to change. This can be varied, and this is all happening at 200,000 times a second no matter what. But you can make it when it's not pulling that much power, just pulse the transformer when it needs to, say 10%. And when it really needs a lot of power, you can crank the duty cycle up to, say, 40%. So you can change the duty cycle versus this, 60 hertz, 50% all the time, no matter what. So there's a difference there. What it really matters, though, is this is refreshing and charging the capacitors 60 times a second, and this is doing it 200,000 times a second. And it can push out power when it needs to and right on demand. So if you have an audio wave and it goes like this all of a sudden, so if you have say just a sub going and you have a really high transient peak, say a kick drum or whatever, and you have this peak that comes up here really quick and sudden, now you're going to have your capacitors are normally going to take care of that. But if you have a lot of these peaks one after another, a transformer like this is going to saturate, and especially with a capacitor bank wussy as this, way inadequate, it's gonna drain really fast, and this transformer is not going to be able to take care of that. So your DC rails are going to start to look something like this, and they're going to start to become pulse DC rather than DC. So let's just say this is a 100-volt rail. Now you're going to have pulses in that rail. That's really bad. You don't want pulses in your DC rails. You want your DC rails to look something like that. Not like that, but straight, 100% straight. You don't want pulses in your DC rails. Now this is because your capacitors are not charged enough. They're being discharged. Now this happens typically in a power supply like this. Not in here, because it's charging them 200,000 times a second, so it's charging them so fast that you never get to the point to where your DC rail becomes pulsed like that. Now this becomes a very big problem in your audio signal, because if you can't deliver these peaks up here, what's going to happen is it's going to clip. So your audio signal going to your speaker is going to look something more like this, because it should be looking something like that, like I showed you, but instead it's going to clip that audio signal, and your output wave going to your speakers is going to look like this, and you're not going to get the full wave. It sounds like crap. It's bad for your amplifier. You're pushing your power supply as much as you can, and it's just not good overall. Mainly it sounds like crap. But this is happening because this transformer and these capacitors are not capable of supplying the power that this amplifier is drawing. Versus in this case, you have a lot of capacitors, you have a power supply that can push out power very quick, 200,000 times a second, and it can change its power that it puts out on demand ridiculously quick, and it can push out those high amounts of power instantly. So it'll switch its rails and everything to fit the needs of your audio signal depending on how much power you're pulling. So if you have a quick pulse like that, or a bunch of them, if you suddenly have a transient peak in your audio signal, and these capacitors and this transformer can't take care of it, you're going to get a crappy signal like this. So it really makes a big difference, not only in weight and efficiency, but in how it makes the power, how it does its whole thing, and how it'll put out the audio signal in the end. You don't want your audio signals being clipped like this. Alright guys, so I'm going to show you guys real quick what it looks like when an amplifier does clip. I'm going to show it to you on the oscilloscope here. So I'll show you real quick. I'm using Smart here to generate 80 hertz. So this is a typical low frequency sine wave. It'd be 80 hertz. That'd be what would going into like a sub. So you'd normally be driving your sub with a lot of power at some frequency like that. So I'm just going to use the knob here and turn it up. You can see the clip light turn on, and we're going to take a look at it on the oscilloscope. So this is pretty good. And once you get up to a certain point, you can see the rails on this, like I showed you guys, the transformer is only 52 volts. So it goes and clips pretty quickly versus a QSC, which will clip somewhere at around 200 volts. So once you start to turn the volume up, you can see it keeps going, it gets bigger, and then right there, your audio, this is a sine wave going into it. It's supposed to look like this. So this is the actual signal that's going into it, but once you start pushing it to enough power, right there, your rails max out right there. You can't push any more power than that. So let's go ahead and save that. Just put it into storage mode and save that. So now I can turn the amp off. So yeah, what that means is right now we're in times 10 mode at 5 volts per division, which means that times 10 is 50 volts per division. So you're just going over 50 volts. Maybe that actually looks a little bit higher than 52 volts, but that's because it's peaking and it's DC, so the capacitors are storing it. So it looks like it's about, I would call that 75 volts per peak. So you have 75 plus, 75 minus. So the rails on this amp are at about 75 volts DC per rail. So that's actually really low for an amplifier. Like I said, the QSC, a typical really powerful amplifier, will have about 200 volts per rail, which will allow a lot more power to be pushed through a certain ohm speaker, whatever your speaker may be, but which means that as soon as you hit 75 volts on this rail, as soon as this amplifier starts putting out 75 volts, it cannot complete the sine wave to put out any more power because the voltage won't go any higher. The amplifier rails don't have enough voltage to complete the full sine wave and to make the actual sine wave. So what it does is it just cuts the wave off the signal and it clips it. That's why it's called clipping. So whenever you see that clip light come on your amplifier, that's actually a bad thing. It's not saying that you're pushing a lot of power. I mean, well, it is meaning that you're pushing a lot of power, but that's not saying that your amplifier should be clipping all the time. It's saying you're pushing so much power that it's actually having to cut your output, your sine wave, off. It's actually clipping it. So that's what that light means on your amplifier. When you see the clip light, this is actually happening to your signal. So that's not good. Now, if it happens every once in a while, maybe, like I said, you have a kick drum, pushes really high frequency transients, that's okay. But if you have your output signal constantly being clipped like this, it's going to sound like crap. Your amplifier, it's not good for your amplifier, and it's just not good at all because you can see you're not getting the actual sound as it should be. You're getting clipped audio with incomplete sine waves, and it's sort of actually turning in, once you get to enough power, it turns into like a square wave almost. Because your waves aren't even like sloping anymore, they're just going straight up and down because your power rails are being drained so quick and are recharging so quick that they just can't keep up with as much power as you're putting out. So that's what it looks like when you push an amplifier past what its power rails are capable of putting out. And that is a lot of stress on the power supply if you're driving that into a speaker, because it's not stressing it out here because we're not drawing any of the power, but when your speaker is drawing that much power to where it clips your power rails, you're maxing out your power supply to its maximum capability, and it can't push out enough power to complete the actual audio signal. So this is about a 3600 watt amplifier, and it weighs, I don't know, 20 something pounds. I don't know off the top of my head. I know for sure this one weighs 40 pounds. And this is a 1,000-watt amplifier. And if you have 1,000 watts constantly going, it's going to sound like crap because it's going to clip. So there's a big difference in power supply technology here. This can push out a lot more power, and it weighs a lot less. It's 2U. This is a 3U amplifier, puts out a lot less power than this, and weighs a ton. So there's a big difference there in technologies. Now, I should always tell you that even though this is a 3600 watt amplifier, the power supplies are never rated for what the amplifiers are set to put out. So if you have a 3600 watt amplifier like this, even though it's only 3600 watts on the output, or even though it's 3600 watts on the output, I don't know what kind of a letter that is, 3600 watts, the power supply may only be rated at, say, 1500 watts or 2000 watts. I don't know exactly. Like I said, it's hard to tell with switch mode power supplies. But this is in a lot of amplifiers. So this 3600 watts, they're assuming that you're only going to be pulling 3600 watts for a certain amount of time, just a short amount of time. Maybe it's a peak or whatever. That is the absolute maximum you can push out of this power supply. That would be at 2 ohms per channel or 4 ohms bridge. So it's relying on this 2000 watt power supply. This can put out 2000 watts maximum at most continuously, and it's going to charge these capacitors. So when you're not pulling 2000 watts, it's going to take that extra power, fill up these capacitors, and then when you pull more than 2000 watts, it's going to use the reserve from these capacitors and the power from this transformer to run it. It's sort of like a battery in a car and an alternator. Sometimes you may be pulling more power, so you're going to use the reserves from your battery, and then when you're not pulling as much power, the alternator is going to charge the battery back up, but it's also going to run the car at the same time. Same principle here, except the thing's going a lot faster. You have 2000 watt power supply constantly going. When you're pulling more, you're using the capacitors. When you're pulling less, you're charging back up the capacitors so that you can reuse the reserve from the capacitors. So you can never run an amplifier constantly at its maximum power. And if you constantly see yourself clipping the amplifier all the time, you obviously need a bigger amplifier. Because if you're pushing, if your amplifier is constantly clipping, you're putting a lot of stress on the power supply. It's not rated to do that. And you're going to want to look for a bigger amplifier, because that's not good for your amplifier, your speakers at all, because you're clipping it, and the amplifier is being stressed out more than it can push out, and it's going to, eventually your amplifier is going to blow up, your power supply will blow up. So you should definitely look for a bigger amplifier if you find yourself clipping it a lot. Because power supplies are never rated for what the amplifier is actually rated to put out. They're rated for the amplifier to put out its maximum power for a certain amount of time, and that's it. So, but usually when you have a switch mode power supply, it can put out that time for a lot more than something like this. So overall, the switch mode is a lot better for many reasons: for its audio quality, for how adequate the power supply is for the amplifier, the weight, the efficiency, everything. So that's just the basic difference between a higher end switch mode amplifier versus a lower end, just a big old toroidal linear power supply with. This is a Japanese amplifier. This is the capacitors in here are they're embarrassing how small they are. You should at least have more capacitors than this, but there's a difference between crappy engineering and good engineering. Like I said, QSC manufactures an amp with these transformers, and they did a pretty good job at it. They have decent filter caps in there and stuff. So it also matters who actually builds your amplifier, not only the technology, but the reputable brand. This is obviously just a Japanese knockoff amplifier, nothing special. This is a reputable brand with higher end technology, better technology running it. So I hope you guys enjoyed the video. If you did, give it a thumbs up. You can comment, send me a message, and subscribe if you guys like my videos. That's pretty much it for this video. Have a good one, guys.